number 4 from Trench 10.5. It's a repeated eigenvalue 2x2 system of differential equations. This is the example of systems, and to start, we're going to subtract lambda from the top left value and the bottom right value. So we're going to get 3 minus lambda, negative 1, 1, and 1 minus lambda. Then you're going to multiply the top left times the bottom right. And from that, you're going to subtract the bottom left times the top right. So that gives us 3 minus 3 lambda minus lambda plus lambda squared plus 1 because it's minus a negative. And just to simplify that, you're going to get lambda squared minus 4 lambda plus 4. Then if you factor that, you're going to get lambda minus 2 squared. So it's a repeating factor, which means lambda 1 is equal to lambda 2, which equals 2. So then from there, you have to make a matrix in order to find your values for K1 and K2 in order to get K1. So you're going to, just like we did up here, subtract lambda from the values, and we now have lambda, which is 2. So you're going to get 3 minus lambda, which is 2. Then keep the negative 1 the same, and the 1 the same. And then 1 minus lambda, which is 2. Which is going to give us zeros. And then from there, just simplify that. So it will be 1, 1, and negative 1, negative 1. Still giving us zeros. And then this is equal to K1, and this is K2. So then, to find your K1 value, you will do K1 plus K2 is equal to 0. And then moving K2 over to the other side, you get K1 is equal to negative K2. And then you can pick any value you want for K2. So I chose negative 1. And then plugging negative 1 back in up here, you're going to get K1 equal to that when you plug it in. So then K1 equals 1 in the end. Then you get K1 with this, and K1 is equal to K1, K2, which you now have. Here's K1 and here's K2. So K1 is equal to 1, negative 1. And then now you have X1, which is equal to K1 e to the lambda t. And we have K1 and lambda now. So it's equal to 1, negative 1, e to the 2t. And now we have to find the second half of the general solution. So we need to solve for p, which we will do with a minus lambda I times p equals K1, where you're going to solve for p because we already have K1. So you're going to use the same matrix we have here. You're going to have 1, 1, negative 1, negative 1. And this time you get 1 and negative 1 out. So in order to eliminate these negative 1s on the bottom, I'm going to add row 2 to our row 1. So then you're going to get 1, 1, 0, 0. You get 1, 1, 0 in the end. And then this is equal to P1 and this is P2. So then just like we did for the K's up here, P1 is P plus P2 is equal to 1. Then, so we're going to move P2 over to the other side just like we did the K values up here. So you're going to get P1 is equal to 1 minus P2. Then we're going to let P2 equal whatever you want. I'm going to choose 0 so it's clean and neat. And then plug it in to what P1 is equal to. So P1 is equal to 1 minus 0. P1 is equal to 1. So now we have P1 and P2. And P is equal to P1, P2, which we have. So P is equal to 1, 0. And then to get your x2 value, the general formula is K1, which we've solved for, T e to the lambda t plus P e lambda t. Then sub everything in. So we're going to get 1, negative 1, T e to the 2t plus 1, 0, e to the 2t. So now that we have both x1 and x2, we can get the full general solution. I'm just going to move that up over here. And that general solution is equal to C1 x1 plus C2 x2, and just a general formula. So then plugging everything we have in, you're going to get C1 times x1, which was 1, negative 1, e to the 2t, plus C2 times x2, which is down here, which was 1, negative 1, t, e to the 2t, plus 1, 0, e to the 2t. And this is the general solution for this system of differential equations.